Hello. This is a stream where I'm going to be solving, well, I'm going to be attempting, who knows what'll happen, Quest 20, the last of the Everybody Codes 2024 problems. I want to say to the creators of Everybody Codes, this has been fun. This has been good. It still feels to me like there are a few rough edges compared to Advent of Code, but you know what? It's good. It's huge. Writing 60 problems all told, even if some of them are kind of related, is a big deal, especially making up input generators for all these problems. Uh, that's no easy task. So thank you. Congratulations on an overall very good debut. I look forward to seeing what you have in the future. So, with all that said, let me go see if Quest 20 is just going to kick my ass because it's too late and I should not be up doing this. We'll find out, won't we? Quest 20. Quest 20. New file. Main.go. I've noticed that a lot of the more popular streamers, when doing anything, keep up a very active banter of what they're doing. And I gotta say, for the people who code and stream, I don't know how you do it. Like I try to talk through what I'm doing, but I obviously don't succeed. There are plenty of times when I'm just silent and doing things and hoping that you can follow what I'm doing. Um, but I, yeah, I don't know how you keep I don't know how you keep up the banter, especially when you're doing one thing and talking about another. Okay, so this is our skeleton code, and of course, the most important thing in this skeleton code, at least how I do it, the thing I kick myself most when I forget it, is to change the input file names to make sure I am referring to the correct input. Okay, we are ready to go. Let's just do a go run Quest 20. Okay, let's get to it. Last problem, here we go. Gliding finale. Part 1. You take a stroll around the city to enjoy some peace while walking in a cliff in the distance. Curiosity peak. You just say, one of the kingdom's screen is nice, or whatever. Surrounded by Shoko's latest invention. You gaze on the structure at awe. The main part resembles a half-cut barrel, where presumably the person using the machine sits on either side. Very long wings are attached. Real wings. Numerous stork feathers are fastened to several lightweight branches on each wing. What a match. Glider can. Okay, all you need to do is learn how to find warm air streams that lift the guide up and cold streams that push it downward. Oh dear. This is going to be fun. For this purpose, one simply needs to wear special goggles that show the temperature of whatever you look at it. Tournament hard sounds. Entire town, the knights, and even the king himself gather a cliff to watch the final round of the tournament. Everyone has traveled a long way, according to drink. Slices around tournament. Final event will be glider races. To understand the machinery, presents a map of the test flight. Single starting point S, which is the cliff you are standing on. You can start your flight in any direction from that point. Warm streams of air are marked with plus, cold streams with minus, and rocky obstacles with. They are located at exactly the same coordinates at every altitude above sea level. Altitude is 0, infinitely upward. glider moves at a constant speed, but it flies quite fast, covering each segment of the map in 1 second. If there are no airstreams, the glider loses 1 meter of altitude while passing through a segment. If it passes through a cold airstream, it loses 2 meters of altitude. Count as a warm airstream, it gains 1 meter. Okay. Altitude at which the glider is located is always an integer. Changes by the rules exactly as said. Glider can only find straight, turn left, or turn right, of course, meaning you cannot immediately return to the previous segment. Below, you can see schematics showcasing how the glider can turn when flying specific direction. Yes. Gaining altitude is extremely critical in glider flying. Before the race begins, every knight has to find a route on the training map, your notes, that allows them to reach the highest possible altitude after the first 100 seconds of flight. The initial altitude is set at 1,000 meters. Initial altitude is set at 1,000 meters. Best strategy is go through a cold airstream. Later, sample flights looks like with the glider marked as G. Okay. Highest altitude possible after the first 100 seconds of flight. G at time 0. Okay, after 7 seconds of flight, you can reach an area of warm air, which is enough to circle around, gaining 2 meters of each altitude with each loop. After 100 seconds. Highest altitude you can reach after the first 100 seconds. So, this will not be... I think this will not be so bad. I can probably... Yeah, I can probably do this without too much issue. I'm a little worried though that my gut instinct and way I would approach it right away is going to fall down even before we finish part 2, because it's just not going to be robust to adding a much larger space. But let's see how big a thing are we looking at here. Interesting. Okay. Um, yeah, so let's see. If we have, yeah, so okay, yeah, screw it. I'm just gonna go for tracking all of the possible paths. And nah, I can't, no, I can't do all of the possible paths. Although many of those paths will end in disaster. So maybe it's okay. Um, yeah. So I will just track the paths and yeah, we'll see where we go from there. Okay. So first off, we have what we always have. or what we almost always have. And I'm just going to okay, so we've got the data read into a byte array, and okay, type point struct x comma y int var start loc point height 0 ifs are sidx slices dot index of scanner dot bytes s no, and then I just say if sidx is greater than or equal to 0, start loc equals point height sidx. Okay, and now we start at start loc. Where we are map from point to int. Actually, no, it's not. Type gstate struct where point dir point, and this will be gstate int, and where, actually I'm going to just say make this because the literal syntax for that bothers me. Gstate of start loc okay, okay, and yeah, so we'll do that. We'll do all 4 cardinal directions. All 4 cardinal directions, and this is for range 100, right? We're just going 100 steps, 100 seconds of flight for range 100. New where equals make. The G state stands for the glider state. make glider map glider state int, and then okay, so glider moves constant speed. Root is okay, so I should turn left, turn right, or go straight, and I should apply the altitude of what I did while I'm there. Yeah. Okay, so for uh, state, comma, height, range, where we are, so then we have 3 different directions to go. For new pause range of point of so this will be state dot where dot x plus state dot dir dot x state dot where dot y plus state dot dir dot y. Okay, so we do forward, we do turn left, turn right. Now I'm not sure which one of these is going to be turn left and which one is going to be turn right, but that's okay. Oh God. Yeah, I need. Oh man, I need more than this. I need new state, G state. These are okay. Why is it saying? Okay. Yeah. So this will be dir. Okay. So this is point. Point state.x minus state dir. Actually, no. We need to swap the y and the x. Point state dot dir dot y minus state dot dir dot x. And then this is point state where dot x minus state dir dot y. Okay, I'm not sure which of those is going to be turning left and which is going to be turning right, but I don't care. Um, as long as this is that, and as long as I don't really care, as long as what I have added to the where is what I have also put for the direction. Okay, so for new state in one of those, um, if new state dot where dot x less than 0, or new state dot where dot y less than 0, or set up the width, or new state dot x dot where dot x is greater than or equal to height, or new state dot where dot y greater than or equal to width. Continue. Okay, if we're out of range, continue. Otherwise, we add the height of the next thing, and then if grid brec new state where dot x, new state where dot y, continue. Yeah, otherwise we add the new height, and then var switch that case continue case plus new height equals height plus 1, case dot new height equals height minus 1, case minus new height equals height minus 2. Now, wait a second. If I hit a state, and I've been in that state on a previous time at a lower altitude, I can just bail. Oh. So I have this where are we thing, but I also need a bin there is also a map. And what we are going to do is we are going to equal or higher. Okay. Um, for old range actually, yeah, if been there of state, if previous state, okay, if previous height is greater than or equal to height, continue. Okay, otherwise, been there of state. So otherwise, we didn't have height or height got higher, so. Okay, and then new where of new state is equal to new height, and then we'll keep going. Okay, I am very worried about off by one errors with this in this solution, but we'll see what happens. Okay, now okay, 20. Really, I find that a surprisingly convenient number, but I also am not inclined to argue it's really late. Nah, damn it. Ugh. Okay, so let's take that. That's the sample input. Let's go and do file, save as, samp. It was a mistake to be doing this recording so late at night. I can tell I am starting to crash, and I may have to suspend this recording and continue it in the morning, or maybe even tomorrow. Oh, interesting. I'm always adding one. 1,000 meters. Wait. So we always go down by one. Oh, wait. So, hold on. Let's go back to this. Close others. If we do this and I cannot do that for max height. I have to do max height at the very end. But also, yeah, also we should have been able to gain more than that. So, max height 0 for range. Oh, duh. It would help if I then here did where equals new where. Range where. Yeah, this is starting to be the effect of it being late and me being tired. Okay, so here's the question. What is going on? dbg len where we are. Okay, we go down to 0 states very fast. Why? Yeah, we should be roughly tripling the states each time. Because after all, right here we start with okay, that's really weird. We end up with one thing at, and we should end up with 3. So zero one zero one. Okay, that's not our start loc though. Okay, start loc started at 0 0. Um, okay, so something is just wrong with our parsing, because we never find the start location. Yeah, we never find the start location. Why? Okay. Let's see. We are looking at the right file. Yeah, of course we're looking at the right file. What is going on here? Index S of byte there gets and a byte. Okay, gets the first occurrence. Okay, wait a second. Oh, okay. So that's at least better. So that was my problem. I had old scanner.scan left in there because I was copying pasting code and hoping that would work. Okay, let's try this. 1025 is all I found. Okay, and according to this, you're supposed to get 1045. Okay. So the question is, okay, so time 0 we're there. Time 1, okay, let me just look at time 3 and see if there is that thing in there at time 3. If tick equals 3. Okay, so at tick 3, we should have something that is at spot at row 1, 2, at row 3, column 1, 2, 3, 4, column, row 3, column 5, headed there at altitude 996. Okay, row 3, column 5. Do I have anything? Row 3, column 5, still heading down. Altitude 996. I do. Okay. And now, what about at 8? 8. Okay, so at time 8, what I should have is one of the things I should have is at row 0, 1, 2, 3, 4, row 5, column 1, 2, 3, 4, 5, 6, 7, 8. Column 8, row 5, column 8, headed towards increasing columns. Row 5, column 8. Row 5, column 8, headed towards increasing columns. Okay, at row 5, okay, row 5, column 8, headed towards increasing columns. You should be at 997. You are not. Okay, so let's check at 7. 7, I should have something that is at row 5, column 7. Row 5, column 7. So after 7, I should have a row 5, column 7 that is there. Seven that is headed that way. Okay, now I've put the, yes, tick 7. The end of tick 7. Okay, so row 5, column 7, headed towards increasing columns, and I am at 994, and I should be at 998. Okay, so time 3 was correct. Let's check time 4. Okay. Time 4, I should have something that is in row 4 there, headed towards increasing rows. Headed towards increasing rows, row 4, with height 997. Yes, and I have that at 4. Okay. And now 5, I should have something at row 5. I should have something at row 5 that is in column 5, row 5, and at height 998. At tick 5. At tick 5, I have something in column 5, row 5, at 998. Okay, now the question is about row 6. Tick 6. Tick. Tick 6. Should have me at row 5, column 6. Row 5, column 6. Row 5, column 6, headed towards increasing columns of 997. Okay, so that we have that. Oh, okay, let's try that. And here we are going to do wait, why is that? I don't understand why I'm running out of heights. 10:45. Yay. Okay. Is that all? Well, yay. 45 minutes in, but okay. 1,000 meters. The map. Reaching point S after pouncing all the checkpoints to land on the cliff. You must at least 10,000 meters at the center of the S segment. Oh, okay. Shortest time to reach all 3 checkpoints and go back to the starting position. Oh, we land on something that is the same height that we start from. Okay, that's not so bad. Because then we don't have to like sit and climb and climb and climb forever. Um, okay, so we have to go to A, then to B, then to C. Okay. Um, first we there anything like yeah, huh? Okay, so sure, let's download this. Let's open this. Well, that's sure confusing. Um, okay, so we only consider things that go to, we start initial height at 10,000, and we only consider things that go to all of A, B, and C in order, and back to S with a height of at least 10,000. Okay. So let's copy this. Copy. Paste. Okay. So case dot A B C. Okay, so yeah. Okay. Now tick keeps going. True. Tick plus plus. And then we break when we get to um, yeah, okay. And then S also does the same thing. And then if this is equal to S, is equal to S, so first off, I start with an extra 0 on everything. So we start at 10,000. And then we say if, okay, so yeah, new where is the case at the end of tick number tick. Okay, so if new height is greater than or equal to 10,000, return tick, else continue. So if we've flown back to start and we are just not high enough, we can't do anything. And so we should go away. Okay, so this should work. This will return -1. Okay, let me make sure did I download my, oh, Yeah, I didn't move it though. Delete. Okay. Now, 8? No, that uh, that's wrong. Clearly, that's horribly wrong. Okay, so I copied that, and then I say save as. Oh, I may have forgotten to go to all of A, B, and C. So it's possible my algorithm was actually totally correct. So here, gstate, and then scene, zero, start, 1, A, 3, C. Okay. Point, comma, 0, comma, 0, comma, 0, comma, 0. Okay. New scene. Current. No, not current scene. Call that state. State.scene. New scene is state scene. And this, I guess I'll just put 0, 0, 0, 0, 0. And then new scene equals state scene. And then here we have if new scene equals 0, if this is new scene equals 1, my ch b new scene equals 2, my ch equals c. Okay, and then new state dot scene new scene. Okay. Then we modify new scene there. So S and new scene equals 3. Input everybody codes quest Q20. Okay, now that says 24. Now am I off by a little bit? I'm not. $5:30. Oh, good. Just over an hour. Well, an hour into the video, I guess. Right when you were laying there, a whirlwind appeared, carrying you further and further from land, higher and higher, way above the far north. When the air stabilizes, flock of mockingbird, bird, exactly that. Meters above sea level, assuming your current altitude. Comes to set. Still see the airstreams. This altitude, they are much sparsely distributed, and strangely enough, they repeat in a certain pattern infinitely to the south. Your notes. So notice that some odd whirlwinds, marked with pound, which you decide to avoid just in case. Good. Everything is still located at the exact same coordinates at every altitude. In the distance, you see faint flashes. It's probably the pyromancers using the spark balls. The warm air streams are too distant from each other. Navigate in a way that allows you to fly as many segments to the south as possible until you reach an altitude of 0. Okay, so notes say that, and then you repeat. Travel south on this map depending on your starting altitude. How many segments to the south can you possibly go with your current altitude? 38400 meters. Okay, so we'll keep doing ticks, but then when new height is equal to 0, then we'll say, okay, that's the maximum you can go. Yeah. We could prune stuff. We could. Let me guess. The input is huge. Oh, the input isn't actually that large. Okay, we could prune stuff, but I'm going to try to not prune stuff yet. Yeah, I'm going to try to not prune stuff for the first pass. Okay, so this will be right. I won't care about. I don't care about the ABC stuff anymore. I just care. Let's go back. So let's copy problem 1 for problem 3. And now I don't really care about the rest. Okay, or so here uh, I'm going to do this substitution that I made before. And um, but I'm going to say this percent height. Okay, so that, and then my okay, that's kind of a lot, but we'll see if it works out. Now what I need to do is if okay, so max row 0. If new height 0, then I do max row equals max of now let me see this here. Can I is there where are the pluses? That okay, so it definitely has to go down. Okay, so these plus lines uh, could keep me kind of afloat. Although, wait, I'm trying to go as far south as I can. So, uh, isn't the best strategy to um, okay, so isn't the obvious best strategy, I mean, just just blindingly obvious best strategy to go left, left, to left, left, down, and then just keep doing that until you hit height 0. I mean, that just seems ridiculous, ridiculously easy a for a part 3, especially given like how complicated this stuff is. Let me look at that pattern again. See, I can't be missing something. Okay, so um, and now we could go No, because we still have to go 2 over. Yeah. So so we might as well go 2 over that way and then down. And then we're going up, down, 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 up, down, 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 up, down, 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 up, down, 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 up. We're just doing that over and over and over again. Okay, so caret position is 33. What if we just go left, left to 31 and then down? I mean, sure. Um, if state dot where dot y, that goes to 31, 33 to 31. If state dot where dot y is greater than 31 and new state dot where dot y greater than equals to state dot where dot y, continue. Less than 31. Okay, so this just shoves it to the and then from there just keep going south. Yeah. New height equals max row max row new state dot where dot y dot x. Okay. I'm wildly suspicious about this, especially after part 2 taken so much compute time. Okay, what is going on here? Oh. Yeah, forget tick. Although also, what? I'm not sure why max row end up is 0. Oh, because nothing would ever. Yeah. Okay, I'm pushing things to the center as hard as I can. or not as hard as I can, but do where we are. If tick less than 10, mt dot print line dbg where we are. Uh, 7. Yes, but why are you not why are you not ever finishing? Uh, well, okay, while that works, I'm going to go and get rid of this stupid pre-flight debug statement that I don't need anymore. Okay, well, I'll push it harder. Well, okay, so this definitely could do with some Golang optimization. Um, yeah, the stupid change I made recently was just to keep it all. Yeah, and I could, um, I suppose, determine after a while that, okay, for every this much in X increase, or take different spots that are identical in the map, I go, it takes me, this much increase in X, I lose this much in altitude, and I might do that as a follow-up optimization, but I don't think I'll do that tonight. I think tonight I'll just wait for this to finish. It won't take too long. It's, you know, clearly going here, and just hope I get it and get it correct. God, I do not want to be one off on this. That would just suck. To have this and have it be an off by one error, that would just and great. I have to rerun it because um, I have to rerun it because here tick. Well, len where we are greater than 0. That was stupid. Um, but yeah, but it didn't take that long to get down to nothing. Anyway, what I was saying is, yeah, this clearly could benefit from some Golang optimization, and I might do that a different night, but right now it is very late here. Um, the stream has been going on for entirely too long. Um, and yeah, like I was saying, I could work out something where if I'm, you know, going down this much and I have a new map segment, then I can just take off, you know, this much off height and add this much to the row. But uh, this program as it is will finish soon enough, and then I can stop this and I'll put it up. And maybe this will give me an opportunity for a better for a subsequent video. Um, I'm not sure what interest there would be in a video where I clean things up, but honestly, I'm not sure what interest there is in a video where I uh, attack these problems, except that if you've watched this far, you're invested in seeing me get that last little duck. I know that that's part of what's kept me going through this is getting that last little duck. So, um, okay. Oh man, I really hope I'm not like off by one. Paste. Yay! Woo! The crowd goes wild. Or not really. Okay. Thank you for watching. Uh, I will be putting this code up on GitHub. The link is in the description. It will be probably relatively ugly in the version of GitHub that goes up when I initially post this. I will definitely clean it up at some point. Maybe I will screencast that cleanup and also optimization. Um, as I was starting to say before, I may a have some videos where I clean up and optimize my solutions, trying to get my various solutions under a decent threshold. In particular, there's one day or one quest. I think it was quest 15, which I did, and it had entirely too long a runtime. I got a hint on Reddit of how I might reduce that runtime by taking advantage of feature of the input. Um, and I will definitely be looking at that, and hopefully I will screencast it so you can look at it too. There should be a link here in the corner. Yeah, there should be a link here in the corner giving pointing you at the playlist of all of my screencasts in this series. Thank you so much for watching. I hope that you got something out of it. Let me know.